In this video, we are looking at coding, which is a way of simplifying calculations by changing them using a code. In this first question, we've got a set of data values x, and we're going to code the data using y equals x minus 3, take away 8. So to find our set of y values, we're going to take away 3 and then divide by 8. So 27 minus 3, 24, divided by 8 is 3. 43 minus 3 over 8, that will be 5. And then we'll have 4, 6, 5, 7, 5, and 56 over 8, that's 7. So we've coded our data, and then we need to calculate the mean of the coded data. So we're going to add them all up and divide by how many? So 3 plus 5 plus 4 plus 6 plus 5 plus 7 plus 5 plus 7 is 42. Divided by 8 is 5.25. Use your answer to find the mean of the original data. So we've got the mean of the y's, and we can say that y bar is x bar minus 3 over 8. So when we've got a mean, if we double all the numbers, we double the mean. If we add 3 to all the numbers, we add 3 to the mean. So we just need to undo this coding. So we're going to times by 8 and then add 3, and that will get x bar by itself. So 8 times y bar is x bar minus 3. 8 times y bar plus 3 is going to be our x bar. So we're going to times by 8, then add 3. So we get 45. And the question for you to try, give it a go. So firstly, we're going to code the data. This time we're taking away 3, then dividing by 5. So we are going to get 3, 6, 5, 7, 8, 7, 8, 5. And we need to calculate the mean of the coded data. So we're going to add them all up. And divide by 8 again. So we get 6.125. So that's the mean of the y's. We'll call that y bar. Use your answer to find the mean of the original data. So y bar is x bar minus 3 over 5. So we're going to undo the code, times by 5, and then add 3. And we get 33.625. A set of data values x is coded using y equals x minus 200 over 10. And we've got the summary data, we've got the sum of the y's, the sum of the y squareds, and n. Calculate the mean and standard deviation of the coded data. So the mean is add them all up and divide by how many? So it's 38.2 over 10, 3.82. The standard deviation is going to be the mean of the squares minus the square of the mean. So 152.6 over 10, take away the mean squared. And we get 0.817. Now use your answer to find the mean and standard deviation of the original data. When we have the mean, we can just undo the coding, because if we add 2 to the numbers, we add 2 to the mean. If we double the numbers, we double the mean. But with the standard deviation, which is the spread of the data, a measure of how far things are from the mean, any adding or taking away isn't going to affect the standard deviation. So if we add 10 to all the numbers, their distance to the mean is unchanged. So for a measure of spread, adding or taking away does not affect. It's not affected by coding, but the timesing and dividing, that is affected. So for our mean, for our x bar, we need to undo the coding. We had 3.82, we need to undo the coding. So we're going to times it by 10, and then add 200. For the standard deviation, adding or taking away isn't going to change anything. So we've only got to worry about the 10. So to get rid of a divide by 10, we times by 10. It's going to be 8.17. So the 200 doesn't affect the standard deviation. Taking away 200, the spread is going to stay the same, but the dividing by 10 will divide the spread by 10. One for you to try. See if you can give it a go. So we need to calculate the mean and standard deviation for the coded data again. So the mean is 64 over 50. Which is 1.28. The standard deviation is the mean of the squares minus the square of the mean. So we have 82.8 over 50 minus 1.28 squared, all square rooted because it's the standard deviation, not the variance that we're working out. And we get 0.133. So that's our standard deviation, 0.133. Use your answer to part B to find the mean and standard deviation of the original data. So our mean, we need to undo the coding. It's affected by the adding and the dividing. So if we undo it, we're going to times by 100 and then add 20. So we're going to have 1.28 times 100 plus 20. And that is 148. And the standard deviation. The standard deviation is affected by the dividing by 100. But adding or taking away does not affect the spread of the data. So to undo it, we're going to times by 100. So 0.133 times 100 will be 13.3.